before I introduce you to the agenda of the session and what we are going to discuss in another 1 hour, I'll just take some time in introducing myself. My name is Amit Bansal. I am basically a corporate trainer and consultant on SQL Server and business intelligence. I have delivered more than 200 workshops and trained more than 3,000 IT professionals on SQL Server. I am also Microsoft's most valuable professional on SQL Server and have about 12 years of experience in SQL Server, starting from version 7.0. I have worked as a BI practitioner with a couple of IT and non-IT companies and had the privilege of speaking at global tech conferences in US, Europe, and India. I also work very closely with Microsoft in India as a subject matter expert on SQL Server. I deliver OD sessions. I've also done content development for SQL Servers, essentially developing hands-on labs for them, and I've been speaking at various MSD and TechNet sessions. I also do a couple of community activities under my MVP profile, like this one, where I'm holding a BI webcast series. I'm also an MCT since 2002, and I am glad to be one of the first MCTs in India and hold a couple of other Microsoft certifications. I am also a member of Microsoft Certified Trainer Advisory Council, where I represent Asia Pacific to Redmond. So this is about me. I've worked with some large companies in India and outside India, and have a major clientele all on SQL Server. So the agenda that we have for today, we are going to first see a small demonstration as to what do we want to achieve. So yes, many of you know that I'm going to demonstrate to you how to create a cube, but I am first going to show you what is the output of data when you extract data from the cube, and then we will see some basics. We will understand some basics before we start diving deep into creating a cube. Then I'll show you a demo on creating a cube. Then we will have follow-up sessions and Q&A. So essentially, this webcast is more of a demo and less of PowerPoint. So you will, about 70% of the webcast is about demos. Okay, so the first question is, what do we want to achieve? Now look at some of the questions that a top-level management or a CEO can have. For example, what has been the total sales in the company? This relatively sounds a very simple question as to what has been the sales in the company, and can very quickly be answered. All you need to do is run a T-SQL query on your OLTP system and get the output. But look at the question. The requirements of the top-level management keep changing. Okay, and see how the questions transform. So the next question would be, what has been the total sales in November 2007? So what has happened? The requirement of the top-level management or the CEO of the company essentially changes, and now there's another query. What has been the total sales in November 2007? Once this answer is given, you have another question coming up. What has been the total sales of employee Y selling product X in November 07 in US distributed by EBC? Now this looks very complex. This essentially is talking about sales figure of a particular employee selling a particular product in a particular year, in a particular month, in a particular region, and the distribution is done by a particular company. Wow, fairly complex. What are the other questions that could be? So what has been the total sales of employees selling this product X in November 07? Or what has been the total sales of employees selling product S in November 07 in US? Essentially, what you are seeing here is the same question is being transformed in multiple ways, and the top-level management wants answers related to the sales figure. So sometimes he wants to see the sales figure employee-wise, sometimes he wants to see the sales figure company-wise, product-wise, distribution-wise, region-wise, time-wise, and it becomes very difficult for the DBA guys or people who are developing reports to keep preparing new and new reports. So the whole idea here is what we want to achieve is an interactive mechanism of analyzing the data. And many of you know that I did a webcast in last week where I showed some functionalities of business intelligence, and this is one of them. So what do we want to achieve? Let's see a quick demo, and I am going to show you a quick demo of how to answer these questions using Excel. So I will switch on Excel. Give me a minute. All right. So I hope all of you can see that I have connected to Excel. And what I am going to do now is connect to a cube that is already built. And where is the cube? Let me show you where the cube is. Right. So in one of my instances of SQL Server, specifically in this one, you will see that I have a queue by the name of Northwind. So Northwind is a queue which is already built, and in this webcast we are going to see how can you create a queue. So let me first demonstrate to you what is the output of the queue. How are you browsing the queue? And then we will see the steps involved in creating a queue. So this is the queue that is already built. And using Excel, I am going to browse this cube now. So what I'm going to do is I go click on the data tab, and in the data tab I have in this ribbon toolbar I have an option here connecting from other sources. So I'm going to establish a connection between Excel and analysis services. It asks me for the server name, and I am going to specify my server name. I'm going to use Windows authentication. Move next. When I'm connecting to analysis services instance, you can see that I have this Northwind database, this OLAP database, which has a cube by the name of Northwind. CEO and sales managers are perspectives. What are perspectives? We don't need to bother about that right now, but what we have to focus on is this cube, Northwind, which is under my OLAP database, Northwind. Move next. I have some default settings here, and I finish. It asks me where am I going to write the pivot table information, so I click on OK. I will put it in the first row, first column. Okay. Now what you essentially see here is that I have a pivot table, and I have a pivot table field list. And you can see a couple of objects are there in the field list. What are these objects? These objects are nothing but measures and dimensions. So what are measures, what are dimensions? We'll talk about it in some time. My intention here right now is to only show you the output of the cube, and then we'll talk about these basics. So what I want to do is, remember the questions that the CEO wanted, answers to which he wanted, total sales. So can I just take total sales and drag it in the values section? If I drag it in the values section, you can see the total sales of the company as on date is visible here. Now let's move on to the next question. The question was, I want to see total sales employee-wise. So you can see that there is a dimension here called employees, and I will take reports to this particular field and put it in row level. And you can see now I am seeing sales figure employee-wise. So Andrew Fuller is probably a CEO or a sales manager, and if you expand, you will see a couple of more employees who are reporting to Andrew Fuller. And there is another guy here called Steven Buchanan, and if you expand Steven Buchanan, you will get a couple of more employees reporting to Steven. Now what do you see? You see that your total sales actually has been sliced and diced using employee data. And you can see the figures have been categorized now. So you can see individual sales figure of each employee, right? This is an interactive way of analyzing your sales data and probably answers some of the questions that the CEO has. Now let's take another question. The requirement changes, and now you want to browse or you want to see the sales figure of each employee according to the time frame. So I want to see how much Andrew Fuller or Steven Buchanan has sold in year 2007, 2008, 2006. So I want to see the sales figure employee-wise as well as time-wise. So I will browse, and you can see that I have another dimension here called TDL time. As I said, what is the dimension? I will talk about it in some time. And how do you come to this output? So I will take time and I'll put it in column labels. And now you can see a matrix or report, a time for matrix report. And you can browse the data. So I can see how much Andrew Fuller has been selling in 1996, 1997, 1998. And if you expand, you will see the sales figure in every quarter of 1997. And if you expand an individual quarter, you will see the sales figure of every month under that quarter. And if you expand a particular month, you will see sales figure on every day. So you can see daily sales of an employee. So this is what is interactive analysis, a drill down analysis that I am doing. And if I want to browse this data further, and I want to see the sales figure of every employee in probably every region. Let me expand region, and I will take country, and let's put it before. And let's look at this interesting analysis now. So what I have done is now I'm seeing the same sales figure employee-wise, country-wise, and time-wise. So I can see how much Andrew Fuller has been selling in Argentina in the year 1997, or in Brazil in the year 1998. And this is how I am browsing my total sales. And I can expand, and I can see the sales figure of Janet. And if I scroll down, I can see the sales figure of Laura under every year, month, quarter, and in every country. So this is an interactive analysis, and I can further drill down to any extent I want. I have product-wise sales, so I can move country and take category name and put it before reports too. So you can see beverages. What has been the contribution of Andrew Fuller or any other employee under beverages category, or under condiments, or under confections? So this is an interactive analysis, and this is what we want to achieve by creating a cube. That is interactive multidimensional drill down analysis on multidimensional data which is stored in the cube. So let me go back and go back to the presentation, and we will see how to create a cube now. So what are some basics? Let's see this. There is a statement on your screen now. You can see we sell products in various markets, and we measure our performance over time. Now this is one of the statements of a top-level management employee, maybe a CEO, or maybe a CFO, or maybe a sales manager. From this statement, you as a BI professional, or you as a data warehouse architect or a data warehouse designer, can figure out that there are three key words here. One is products, another is markets, and another is time. And what is meant by products, markets, and time? Basically, the statement here means that the top-level management of the company wants to view the sales figure product-wise, they want to view the sales figure market-wise, that probably could be region, and they want to see the sales figure time-wise. 2007, 2008, 2009, so on and so forth. And technically, what does this mean to you? Technically, let me show you what it means. Look at the question, what was the total, let me go a step back. What was the total amount of sales and if you look at this cube, do you see time, market, product, these three dimensions here? And let's understand this in greater detail now. What was the total amount of sales of all microwaves? So microwave is a product, right? Microwave is a product. Amount of sales, so this is a measure. What is the measure? A measure is a numerical value that you want to analyze. So sales figure, total sales, discount, unit sales, profit margin, percentage, net profit, gross profit, all these are numerical figures that you want to analyze. And technically in BI, in SQL Server analysis services, you term it as measures, right? Microwave. So microwave is a product which becomes a dimension. So product becomes a dimension in your cube. So you can see a product dimension here coming up. And you can see how you are slicing the cube, storing the multidimensional data. The next question is at one large chain. So what is chain? Chain here means market. Chain here means market. This is also one of the dimensions, and then you will see market dimension. So the cube gets sliced again. So you can see some sort of slicing and dicing that is happening. The next is in January 2004. So January 2004 is time, right? So you want to see the sales figure of microwaves in one large chain in January 2007, and you have your third dimension coming up, that is time. And you will see the cube gets further diced with time dimension. And yes, the intersection, and you will see the intersection of these three dimensions is actually the value that you want to see. So let's do a quick recap. So measures is something that you've understood. It's the numerical value that you want to analyze. So what are dimensions? Some of you might still not be clear as to what is a dimension. Before I explain you dimension, let me explain you what is the fact. There is a concept of fact table, or simply term it as fact in BI. Fact, dimensions, and measures. Fact is your actual data, what we term as a factual data. Every single record, every single sales record is termed as a fact, a transaction that has factually happened. So a fact record will have the sales figure, it will have the information of customer, employee, product, quantity, time of sale, date of sale, so on and so forth. So that's a fact. In your data warehouse, you will have a fact table which will actually have all the records, all the transactional records. Now, that factual data is of no use unless you slice and dice that data with the help of dimensions. So, three dimensions that you have here is time dimension, market dimension, and product dimension. So you can see time, market, and product. What does the dimension allow you to do? A dimension basically allows you to categorize factual data. So if I want to see that factual data time-wise, I want to see that factual data market-wise or product-wise. Dimensions give meaning to that factual data, allows you to slice and dice the factual data and view them into categories. And this is essentially what I did in the Excel. When I put the total sales, which is a measure, and then I dragged a few dimensions in rows and columns, I was basically slicing and dicing that sales figure, right? So, measures is the numerical data that you want to analyze. Facts are the factual records that consists of all the information, and dimensions are units that will allow you to categorize your factual data. So with this basic, I will move on, and the next thing that I'm going to do now is prepare a cube for you. And this is what I'm going to do now. I'm actually going to prepare a cube. This is the portion that we are going to work on. So in the process of creating the cube, I will first create a small mini data warehouse. So before I start my demo, let me give you feedback. I have an OLTP database by the name of Northwind. All of you must be aware of Northwind, which is a sample database that comes with SQL Server 2000. And what I'm going to do is I'm going to prepare a small mini data warehouse from that OLTP database Northwind, and then I'm going to create a cube. After I create a cube, I am going to deploy it. After I deploy the cube, I'm going to browse it in Excel, exactly the same way as I showed you before. So let me proceed. So let's start with creating a cube. Okay, so this is the tool that I am going to use to create a cube. Um, Visual Studio 2008. Basically, I'm using Business Intelligence Development Studio, which is actually a subset of Visual Studio 2008. I create a new BI project in this file, new project, and I am going to create a project. I'm going to create an analysis services project and just name it as Northwind NW sample, and I'm going to browse it in my folder. People where events BI 06 the customer, and I will look at this folder. I'm going to click on OK. Now, the moment I create this project, you can see a couple of folders there, right? You can see data source views, you can see cubes, dimensions, mining structures, roles, assemblies, and a couple of other folders. We're not going to work with all the folders. We'll start with data source. What is a data source? A data source is a file that defines your connection to your OLTP source. That's what it is. I will first create a new data source. So the data source wizard pops up. Click on next. I am going to create a new connection. My server name. So this is my server name. SQL Server 2008, you can see SQL 228, and I am going to select my database. So I can connect to Northwind, which is here. The connection succeeds. Hit on OK. Move next. I am going to, so it gives me credential information. I am going to inherit. Inherit simply here means that I am going to connect using Windows authentication. Move next. Give it a name, and I'm going to give it TS underscore Northwind. And if I double click on the data source right now. Now, the question is, I've created a data source and I'm going to connect to Northwind. Now, before I proceed further, let me take you to the Northwind database. This is the instance that I'm connected to, SQL 2K8 instance 1. And if I expand the database, you will see I have Northwind here. Now, in Northwind, I have this table structure which has a couple of tables. But this is my OLTP database, and these are my transactional tables. So you have orders, you have master tables like products, you have a transaction table like order details, which has the order details of each and every order, customer, employee, so on and so forth. Now my intention is to create a mini data warehouse. That is, I'm going to create a set of tables. So there will be a fact table which will have all the factual records, and there are going to be a few tables which will have dimension records like employee, geography, so on and so forth. So let me create a new query, or I will get existing query. Okay, so here is my query to create a time dimension. I'm not going to go into the detail of these scripts, or else it will be very time consuming. All I'm going to do is create a table by the name of TBL time, which will have time key, order date, year, quarter. What essentially this table will become a dimension in my cube. In my relational structure here, it will be called as a dimensional table, and in my cube, this will become a dimension. I am going to select my order date, year, quarter, month, so on and so forth from table DBO orders. So let me create my time dimension. I select all of this and execute this, and I get 480 rows selected. So I am going to I've created a time dimension now. Next, I am going to create an employee dimension. So if you look at the code, the script of employee, it's very straightforward. I'm going to create a view which will select the employee ID, last name and first name from the underlying employees table. It's as simple as that, because I want to browse the sales figure employee wise. So employee becomes a dimension. Select this, quickly create my employee. Next, I am going to create a geography dimension, and you can see it has postal code, city, region, country, and I'm going to select all this data from my table customers. This creates my geography dimension. Next, I am going to create a product dimension. Remember, we want to see the sales figure product wise also, so I'm going to create a product dimension which has product ID, the product name, the category name, and I am going to do an inner join with the products and categories tables and create a product dimension. Next, I want to create a shipper dimension also, so I create a shipper dimension. Shipper dimension will only have shipper ID and the shipper name, which is basically the company name. Finally, I am going to create a dimension called supplier dimension. So I also want to see the sales figure supplier wise. Which supplier has delivered the sales figure to which particular region. So I want to see the sales figure supplier wise. How much work business each supplier has done and execute. So in essential, if I refresh my tables here, you will see TBL time, which is being highlighted here. This is the only table which is TBL time is the only table here, which is a dimension. Rest of the dimensions have been created as view, and you can see all of them here: employees, geography, product, shippers, and suppliers. Yes, friends. So we are missing something. Yes, we are missing a facts table now. Finally, a facts table. You have about 6 dimensions. Now is the time to create a facts table. And here is the script for a fact table. Again, I will not go into the detail of the script. I'm going to create a facts table, and as I said, fact table will contain factual data, which is nothing but your transactional data, one record per order detail. So I am going to have order date, postal code, product ID, employee ID, shipper ID, and these are my measures: total sales, discount, and unit sales. So these 3 are your measures. Rest of the factual data will help you connect this fact table with dimensions. So many of you have already understood the concept behind it. I have a product dimension which will connect to this fact table using product ID. I already have an employee dimension which will connect to this fact table using the employee ID. I already have a shipper dimension which will connect to this fact table using the shipper ID, so on and so forth. And yes, I have the time dimension also which will connect to this table using time key. So this has some script code here, doing a couple of inner join, doing a couple of execution. So let me select it all and execute it. So I have 2,155 rows in my fact table. And what I'm going to do now is go back to my a mini data warehouse is ready with one fact table and about 5 to 6 dimensions. This is sufficient enough for me to create a small queue which will be based on this data warehouse. I am going to connect to Management Studio, BI Development Studio, and we had this data source ready. Now I am going to create a data source view. So what is a data source view? A data source view is just like you have a view, which is a view on top of a table. Our data source view is nothing but an object file, which is an abstraction between the queue and the data warehouse. Let me create it, and then you'll have a better understanding. So I created a new data source view. I need to select the data source, so I'm going to use the data source that I created in the previous step. Okay, I have a couple of objects here. I am not going to use all the objects. The one that I'm going to use is my timetable. I'm going to use my facts table. This is CBS facts, and I can filter. You remember most of our dimensions were views which started from PW. So I'm going to take all these and move next. So what I've done is I have all the 6 dimensions and my fact table. This is sufficient, and I move next, give it a name, and I will give it DSV, that stands for, so prefix it with DSV underscore note and finish. Okay. Now what you can see that you have all your tables, but they're not related to each other. I'm going to set relations now. So what I will do is, in order to set relations correctly, I will first zoom out, bring all these objects near fact table. And the reason why I'm bringing all my dimensions near the fact table is because TBL fact is a fact table and all these are dimensions. And what I am going to do now is set relationships between them. How am I going to do it? Postal code is going to be linked to postal code in geography. Now it gives me a message. The destination table of the newly created relationship has no primary key defined. Would you like to define a logical primary key based on the columns used in this relationship? Yes, I want to define a logical primary key. What is meant by logical primary key? See, any modification you do in this table here, like creating a primary key, is not going to be affected in the underlying data warehouse. That's the purpose of this data source view. So the relationships that you define are only going to be available for this data source view. It is not going to affect your underlying data warehouse. So your underlying data warehouse can be reusable for other projects also. So a data source view is an abstraction between your data warehouse and your cube structure. What essentially you're trying to do is here is define a cube structure. And I'm going to link product ID now to product ID. I'm going to link employee ID to employee ID, shipper ID to shipper ID in my dimensions table. Total sales, discount, and unit sales, as you know, are measures. Finally, I have time key, which I'm going to link to the time key in my dimensions table. And time, TBL time also does not have a primary key, so yes, I want to create one. Suppliers has product ID, and I'm going to take product ID to supplier as well. Now, what you have formulated here is like a star schema. This is technically called as a star schema, where you have a fact table and you have dimensions which have one-to-many relationships with the fact table, and this is essentially what you saw in the PPT. And if you remember, so I hope all of you remember, this is what we created. What we have done is created a star schema where we have a fact table and a couple of dimensions surrounding it. Basically, all the dimensions have relationships with the fact table, and the relationship is one to many. And I will continue with my demo. Great. So back to the screen where we are through with creating a data source view. So a quick recap. We created a mini data warehouse out of our OLTP database Northwind. Then we created a data source, and then we have created a data source view which is based on the underlying data warehouse. The next step, which is one of the most important steps, is to create a cube now. So I'm going to create a cube which is going to be based on this data source view that we have just created. Right click, new cube, and I will move next. How do you like to create the cube? I am using an existing table. No, I will just. So what we are going to do is, there are three options: creating an empty cube, generating tables in the data source, and using existing tables. So as you know, we have already created our table, and we are going to use the first option. Move next. So it tells us to select the data source view. We have only one data source view, and we select that. And if you click on suggest, it will suggest you which table is actually a measure group table. And you know that TBL fact is your measure group table. What is a measure group table? Tables that contain your measures. And you know that TBL fact contains total sales, discount, and unit sales, which are your measures. Move next. Now you need to define your measures. You know that total sales, discount, and unit sales are measures which are individual columns in the table. But you don't have a column by the name of TBL fact count. Well, this is automatically added by SQL Server Analysis Services to keep a count of the number of records that you have in fact table. So you might not need it. In case you need it, you can always have it, but I don't need it right now, so I can uncheck it. Next. Now you need to select your dimensions, and you know that these are all the dimensions that you want to use. You want to use geography, products, employees, shippers, time, and suppliers. Move next. Give a name to your cube, and we are going to give it cube underscore Northwind. Finish. Okay, friends, we have our cube ready. And you will be a little surprised to see that the structure of the cube is very similar to the structure of the data source view. Yes, indeed, the structure has to be similar because all these are dimensions. All these are dimensions, and the one in yellow, TBL fact, is your fact table, and these are your dimensions having one-to-many relationship. A lot of panes here. There is a measure pane here. There is a dimension pane here, right? And a lot of tags here like dimensions, usage, calculations, KPIs, actions, so on and so forth. These are all advanced development techniques with the cube, which is beyond the scope of this webcast. In this webcast, I'm showing you how to create a cube, and the cube is almost ready. But before I make more modifications to the cube, I first want to deploy it, and I want to see how it looks like. So what I'm going to do is, right-click the project properties, and there is a section here called deployment, and I'm going to select deployment. Okay, the server name says localhost. Well, my server name actually is my server name and the instance equal to it, and the database is NW sample. That's fine. So this is going to be the OLAP database. Okay. right click and process. What is process? Before you process, you need to deploy. Deployment means that an OLAP database is going to be created in Analysis Services Engine. After an OLAP database is created, my cube is going to be processed. By process, what it means, it is going to extract all the data that is there in the data warehouse and store it in multi-dimensional format in the cube. This is what is done with the help of processing the cube. So I click on process. It tells me that, do I first need to build and deploy the project? Yes, I need to do that first. And on the right hand corner of the screen, you will see that deployment and processing has begun. So since it's a very small project, it's a very small cube, deployment is done quickly, and I'm going to, this is my processing dialog box. With all the default options, most importantly successful, I'm going to do a full process, and I click on run. And the processing is complete. So I successfully processed the cube, I close it, and one of the tabs you're going to see here is browser. As a BI developer, it is important, and you would always want to browse the cube before you finally deploy it in production server, and you would want to check that everything is fine. You can always browse, that means test your cube. Are you able to do analysis and do interactive, and are you able to interact and browse the cube? Now, when you see the cube, you named it cube underscore northwind, which is being listed here. Your measures are here. Discount, total sales, and unit sales, and all your dimensions are here, right? You can see all of them here. And but interestingly, under every dimension, what you see is only their primary keys. You can see time key, you can see employee ID under employees, you can see postal code under geography, you can see shipper ID under shippers. So by default, all that you see for every dimension is only one attribute, that is the ID of that particular dimension. Let's do interactive analysis now. This is something similar to what we did in Excel. So this is again a pivot table component of the Excel. So it's the same component, and I'm testing it right now. So I will take total sales. This is my total sales, and this is the same sales figure that you saw in the Excel demo. And I want to slice this data with employees, and I will take it in row. And this time, instead of getting the employee names, you're getting employee ID. 1, 2, 3, 4, 5, 6, all the employee IDs. You want to see this sales figure time wise, so I can take TPL time and I can put it here. And all that you are getting is time key. So the only thing that you are a little upset, we are a little upset is that we are getting all the IDs, but we're getting no names. So if I remove this field and I want to see product wise, I want to slice it product wise. And then if I take product on the column, again I'm getting product ID. So a little annoying, right? Now as a BI developer, it is important that you have to make your cube a little more intuitive, because you have all the IDs, it's very difficult to analyze. In such a case, now what you need to do is you have to go back to the cube structure and make a few modifications. So some essential modifications that we are going to do now is first is employee. So you can see all your dimensions are listed here. I will go to the employee dimension, and you can see now I'm actually modifying employee dimension, and you can see employee ID is being listed here. And I can quickly take employee name and I can add that as an attribute. But there is a better way of doing it, but I am not going to discuss that better way. That better way is basically going into employee ID, going into properties, and then changing the key column, and then changing something called as the name column. I'm not going to do all that because that will be a little time consuming. So I quickly take employee name, save it. Then you have products. I have product ID. I'm going to quickly take product name, save it, and time dimension. I had time key. Let me take year. And okay, I will make order date, quarter, month. I will spend some time because on time dimension, because time dimension is a very important dimension. You will never see a BI solution. Probably I have never seen a BI solution without the time dimension. Time dimension will allow you to browse your numerical figures time-wise. As I showed you, I want to see the data year-wise, quarter-wise, month-wise, and day-wise. Now, this is a pretty flat dimension, month, order, date, but I want to convert it into a hierarchical dimension. So here comes another concept of hierarchical dimensions. I am going to take year, I am going to take, so quarter comes after year. This is how I want to drill down, and then I want to take month, and then I want to take the order date. Now what happens? In the hierarchy pane, I'm actually trying to create a hierarchy by the name of calendar, and I will just rename it to calendar, and I have a hierarchical dimension now where I can drill down from year to quarter, quarter to month, and month to order date. You can see a couple of crooked underlines here. You know, these are known as squigglies. Blue squigglies are warnings, but don't need to bother much about them right now. I'll save it. Is there anything else? Supplier, take supplier name, save it. Shippers, so you have shipper ID, take shipper name, and save it. And as you know, you have made a couple of modifications. You need to deploy in process again. So I click on process. First I will deploy. Okay, and we run it. So we are through. We have processed this cube again. I can go back to the browser, and you can see the cube has been processed on the server. So I just need to reconnect and refresh. So I will reconnect. And just clear the results here and start all over again. I will take total sales and employee name. Wow, so here you get employee name now, so you can see what has been the sales figure of each and every employee. And you wanted to see this data time-wise, and I can drop it on time. So I can see how much Stephen Bitumen sold in 1996, 97, 98. I can further drill down in 1996 and see my 2 quarters, or third quarter and the fourth quarter. I can expand quarter, and I can see the sales figure in 10th, 11th, and 12th month, which is essentially October, November, and December. So I am able to browse the cube interactively, and I'm able to analyze the data the way I want to see it. After I save all of this, and you can further drill down by shipper name. So, you know, Stephen Bitumen expanded. So he has been shipping through Federal Shipping, Speedy Express, and United Package. And these are the sales figure on every month, quarter, and year. Interactive analysis. Browse the data as you feel like, know the figures you want. No need to go back and keep writing, keep modifying your SQL statements, and keep creating dozens and dozens of listing reports. All that you need to do is just give this cube, probably the sales cube, to your top level management and tell them to use Excel to analyze the data and to see the data they want. And let's go to Excel now and browse this cube that you have created. So I'll go to Excel, go to sheet 2, create a new connection from analysis services. My server name, as you all know, SQL this one. And NW sample was the OLAP database, and cube announcement was the cube that you have just deployed. Move next. Finish. And here we go. Total sales in values, employee name on row figures. I can't see time, so here is time, which will be on column, and here you get the same data, right? Well, you can also do conditional formatting, which is a feature of Excel, like data bars and so on and so forth, which will give you more visual, appealing stuff here, right? It's up to you. You want to do a further drill down, you can always take shipper ID after employee the way I did it. And the beauty of this interactive analysis is you can reverse the roles. Like right now, you are seeing the shipping companies under employee. Go back to this pivot table and move shipping before employee, and it changes. So you first see the sales figure shipping company wise, then you expand a particular shipping company and see the sales figure shipping wise and then employee wise for every month, quarter, and year. Browse as you feel like. So this is what I wanted to show you in creating a cube, and we did a few steps, and you can see how easy it was to create a cube. Pretty straightforward. So I come to a close of my presentation, and this was just a tip of the iceberg on just creating a cube. There are many more things that you would want to do, and in BI there are many more things like T-SQL, data warehousing, different components of Microsoft BI platform like SSIS, SSRS, which you might be interested in. We have seen Excel as a BI client. BI can be integrated with SharePoint. We have another product from Performance Point Server. There's data mining, DNX, a lot of other tools to work with BI. So, I mean, a learning path could be like this. Follow-up. First and foremost, please join my forum, betogether.in, where we can have continued discussions. It's a Google group. You may just have a Google account and you can become a member. For your information, this presentation is going to be available to all of you in betogether.in. All you need to do is just be a member and download this presentation for files. You can subscribe to my blog where I frequently write about SQL Server and BI. You can follow all the stuff that I do in SQL Server BI, my webcasts, presentations, and a couple of other things on Twitter. Please go and give me a feedback on my personal site, amitbansal.net. Just visit this URL. At the bottom of the screen, you will see sign my guest book. Please give me a feedback on how did you like this webcast, so that I can further improve. If you want to connect with me, you can do that using Facebook and LinkedIn. Okay. Just to let you all know, I am also doing a 4-day course on SQL Server 2008 Analysis Services, and I'm doing it across 7 cities. You can visit this URL to find out more about this course. This is an excellent course that I've designed. 4 days, 36 hours, deep dive sessions on business intelligence, analysis services, data warehousing, Excel dashboards, so on and so forth. Or you can call it this number to know more about this course. So this is the place where you need to sign my guest book, and please give me a feedback on this URL, whichever is convenient. So time for Q&A, and I will invite questions now. I have about 15 to 20 minutes to answer your questions. So I have a question from Amlan. There can be more than 3 dimensions also. Amlan, yes, there is a question. Yes, there could be more than 3 dimensions. As you saw in the demo, we had about 5 to 6 dimensions. You can have hundreds of dimensions. Yeah, someone is asking me about corporate training in their company. You can please, if you have dedicated corporate training requirement in your company on SQL Server and BI, please call it this number. So, or you can just probably email me if you need so, amit.bansal@peoplewareindia.com. This is my email ID in case you have some training stuff requirement in your company. I will move to technical questions. Satya, thank you so much. It was a pleasure having you. Can I use a cube created in Cognos in SSAS? That's a question from Paranikaran. Paraykaran, you cannot create a cube that is created in Cognos. The cube has to be created in SSAS itself. So there's a question from Sandeep, how do we decide the measures and dimensions? Well, when you understand the business context of the data warehouse, when you understand the business requirement, you will be able to figure out measures are always going to be numerical. Measures will not be alphanumeric. Measures will not be alphanumeric data. It will always be numerical figure on which you can do aggregations like summing, average, minimum, maximum. And dimensions are basically conceptually, dimensions are nothing but categories on which you want to drill down the data. I want to drill down on employee, I want to drill down on region, I want to drill down on time, but I never want to drill down on measures. So conceptually, you will be able to figure out which is the measure and which is the dimension. Raghuram has a question. Can this cube deployment be done through SQL Server 2005 too? Absolutely, you can deploy this cube in SQL Server 2005 also, but you cannot deploy this cube in SQL Server 2000. So in my deployment box, I gave my target server as a 2008 instance. I could have given a 2005 instance also, because you know that the architecture of 2005 and 2008 is same, but you cannot deploy this cube in 2000. Thanks. Okay, Satya has a question on doubts on cube in advanced level. Satya, I request you to post your advanced questions on cube in my forum btogether.in. Probably this would not be the right forum for your question, so I'll request you to be a member of btogether.in and please post your question there. I will answer it there. Amlan has a question. Is it online with actual data, or does it need, or is there some lag time? Well, Amlan, it depends on business requirement. Most of the time, there is a lag time of about maybe an hour, maybe 6 hours, or maybe a night, or maybe 12 hours. The reason being is because in real life scenarios, cubes process huge amount of data and they take considerable amount of time. In real life scenarios, cubes will process for hours and hours. So at that point of time, you can't keep the cube up to date with your OLTP data, or you cannot have the cube show you real-time data. However, it is technically possible that cube will show real-time data. In such a case, the data will not be stored in the cube. It will be stored in your relational warehouse. Then what would happen? You will be able to see real-time data, but you will not be, but the query performance is going to be very poor because you will be browsing huge amount of data. So practically speaking, there is always a lag time, but both the scenarios are possible. In real life scenarios, having a little bit of lag time is not a problem because the figures, the total fields, the measures that you are browsing is only for analysis purpose. It's not for, so I mean you're browsing millions of records. So if a few records are missing, your predictive analysis is not going to affect too much. So Prabhakaran has a question about recording. This session is being recorded, and after the session is over, you will get an email from Microsoft where you can download this presentation. How about security extensions in SSAS? In SSAS, there is a role-based security, which works like Windows authentication. So that's the only authentication in SSAS. So Deepak has a question. We have to browse our database file through Visual Studio. No, not necessarily. Deepak, browsing the cube from Visual Studio is only going to be done by the BI developer for testing purposes. But the top level management, who is the actual consumer of the cube, will probably use a front-end client like Excel. Why is it called cube, not tensor or something like that? Amlan, it's called a cube because pictorially it looks like a cube, having dimensions like X, Y, Z, A, B, C, so on and so forth. So we're talking about length, breadth, and depth. That's the reason why it's called cube. BI as a term was coined in 1956, and since then this concept has been coming up. So since I'm not the one who has created these nomenclatures, I really do not know that why it is called cube and why it is not called something else. Sure, Satya. Thanks for joining the group. I will improve it.